All right, let's get started. So this evening, we're going to talk about schema design, which is the process of coming up with the layout of a database. Oh, that's so nice. Yay. It's basically the process of modeling your data in such a way that it can go into whatever container you want to put it in. So the questions we're trying to answer when we're doing this are, how do I represent the actual relationships and properties in our program in a way that our program can digest, in a way that makes writing the program easy. So we're trying to minimize the amount of work we have to do, while remaining flexible for changes we might want to make in the future. This one is hard, right? Because you never know what the future entails. And so in general, I lean against making decisions because we want flexibility in the future, because 99% of the time you over-design something for a use case that never happens, because you go in some different direction, or because your startup fails. So that's a very common thing, right? So I prefer writing for the now, which of course has the other problem that sometimes you write for the now and then a month later you're like, well, that was, now I guess I get to rewrite it. And then we also care about performance. We don't necessarily care about performance that much, but we can make sort of some easy trade-offs, or even make some decisions that are just pure wins in terms of how we represent the data, so that it doesn't become overwhelming for the database later. So when we design a schema, we sort of go through these big steps. We ask, what is my program going to need to output? So what are we going to display? And what data are we going to take in? So if I'm making Facebook, I'm thinking about okay, I need to, what do I need to do? What are the problems I need to solve? Facebook's a really big one, huh?
Yeah.
Yeah, okay, let's take a simpler one, Instagram. That is definitely smaller than Facebook. Facebook has groups and all these, and the feed and events, and they have so many different user groups, you, your mom, Russian trolls, everyone. They care about all of them.
Instagram, you basically need, yourself and the pictures that you posted, which need to come back in order, and then you need your followers and people who follow you.
Right. So you have, basically the main view in Instagram is a bunch of photos in chronological order. Yeah, they're not in chronological order anymore. In fact, none of these things are in chronological order. They're in some order. And that order can be defined by something. This is actually an interesting question, right? As these major internet destinations move more and more towards algorithmic modeling of your experience, some people don't like it. I don't particularly like it, although I do kind of rely on it, right? It's I'll retweet things and not worry, oh, am I flooding my friend's feed with retweets of this tweet? And I'm no, Twitter wouldn't do that. That would be a terrible experience. So I'm sort of relying on some degree of algorithmicness, and the issue is when you don't really get a choice how much, and that you don't have insight into the algorithm that's driving your dopamine reward cycle. So you want to think about what views you have and what data you're trying to collect, and what data you're going to need in order to produce that output. So for Instagram, for example, it's we want to be able to get filtered views based on hashtags, and something at some point needs to filter them chronologically. The robot needs to see a chronological view so the robot can reorder it to maximize your ad revenue for Instagram. And then on top of that, we're okay, in order to solve these problems, how do we need to lay out the data? So we come up with sort of a conceptual design of the different entities and the relationships between them. And we'll look at an example of that in a second. And then we can go from that conceptual design of like, okay, I have, say, posts, and a post has many comments, and a comment has many hashtags, and posts also have many hashtags. We can sort of go from that layout to how would I represent this in a SQL database, that's what we're going to be doing today. If you're using a NoSQL database later, you would ask, how will I represent this in like Cloud Firestore? And the answers are actually like not completely dissimilar, although there are different trade-offs you make depending on the kind of database you're picking. And then finally, there's the physical design, which is like the last step. Like, what do I actually have to do to put the database in this state? And that's the part we're not going to worry about today. So we're just focusing on the first few chunks. Your deliverable for this workshop is a like logical diagram of what your database would look like. Okay. This is. Oh yeah. Sorry. I'm like, this is the same slide, but it's a slightly darker green. Yeah, so let's talk about this is my fault, I think. it looked brighter on my screen or something. Okay, so let's look at an example of how we analyze a problem. And the problem we're going to analyze is this. I want a program to keep my journal in, and I want to be able to enter the text of each journal entry, and I want to be able to see journal entries chronologically. Chronologically Instagram, not any other, not how some robot thinks I want to view my life. Okay, so what are some, okay, so that is, this is say like the end result of like me thinking about like what I want out of my journaling program. So let's talk about like the conceptual design of this. What are the entities we have in here, and what are their relationships? Thoughts?
A journal has many entries.
Yeah, so I've got a journal which has many entries. Arguably, I don't need the journal as an entity because there's only one of them. You're right that like, hey, maybe you want multiple journals is sort of a reasonable thought. Like probably I will want multiple journals. What else? What is what does an entry have? Yeah, it has a date or a timestamp and some content. Yeah. Behold, that's what we got. And you can imagine there's like a journal has many entries if you sort of want to support multiple journals. Okay, so how would we make this happen in SQL? Logical design. Or not necessarily in SQL, but just in a relational database, what table would we create? Oh no, I've said too much. Yeah?
Once we create a table called journal,
Mm-hmm.
and it'd have a column called body and a column called like text.
Yeah, that sounds great. So, yeah, I guess I called it entries, which makes sense because it's like for an entry. And it's got a timestamp or the date created and the text. If I want to explore multiple journal, wait, no, that's the next step, sorry. Okay, so far so easy. We're all done. Except, of course, I forgot some requirements, as you do. So now I want to have multiple journals. And I also want to have hashtags, because I'm a millennial. So I want to be able to find all entries with a particular hashtag. So now what does my entity relation diagram look like? Like, what new entities do I have?
Journal entity, and then that would connect to many journal entries.
Mm-hmm.
You have like another journal, and I want to say that you then want to make a separate table that just explains the relationship between the entries and your journal. The separate journal,
Yeah. Yeah, so that, you described like 2 layers of analysis, which is great. We'll have a journal which has many entries, and we can implement that in SQL. And then what about hashtags? Yeah. Yeah, no, that is exactly what it's called. Cool, yeah, so we can have a, oh yeah, and I don't know if I said a journal has titles. I didn't say that, but I guess I put it on here. So yeah, so now we have a journal entity, and a journal has many journal entries. It also has a title, I guess. And a journal entry has many tags, and each tag has a name. So we've added all this stuff. And then people basically said it, so jump forward. Here's a way our logical design could look. We have a journals table, which has the title of each journal and an ID for each. And then each entry has a foreign key, like what journal owns it. So this is like the journal ID. And then this was mentioned, so I'll jump through these slides. How do we relate these? Yeah, exactly. We can have a entry tags join table. So why is it that in order to relate entries and journals, I can have a journal ID column, but to relate entries and tags, I can't have a tags ID column? Yeah, it would have to be tag IDs, and what would go in there? Like all of the tag IDs, which actually is something you can do in Postgres. You can have an array. Those are like a little bit irritating to query, it turns out. They're sort of not the classic way of designing a relational database, and you will see like a bajillion join tables in your life, and it's a very heavily optimized code path. So this is how we like to teach it. In like some later workshops and stuff, you'll see arrays, and you can look up the documentation on how to use them. There are some good use cases for them, I think, at this point. Yeah.
So just to clarify, in like entry tags, the foreign key of say tag ID would be the primary key in the tags.
Yeah, exactly. So this relates the primary keys of two tables, making it a joint table, and the two tables are entry ID and then tag ID. Okay, and then we already talked about this, so like, oh yeah, but actually why not do this? So we have, instead of having a separate tags table that relates a string tag to an ID, why not just say we have tagged entries that relates an entry ID to a particular string, which is a tag. It doesn't seem like categorically worse, right?
Can you have multiple tags for entry? Not multiple stuff
No, because I can have like 50 rows in here with the same entry ID and different tags.
But the entry ID will be unique for each journal. I mean, you can have multiple entry ID for different journal.
Yeah, it's just like here. Only we sort of decompose, because this is a one-to-one mapping, right? This actually should say unique. Like each tag has a unique row here. We're just kind of decomposing the row of the tags table into this table. So it doesn't like change its queryability. It's not like we're making some assumption that we weren't making before. But there's a reason to prefer this to this. Sorry. No, someone should talk, but go ahead. No, let's say something.
So you could like update the tag name for the same. Like you want to use an ID rather than like a string, because if it's the same tag but you change what the string is, then it's not gonna like go to the right place.
Right. So what happens here, and this is like arguably not a great use case to demonstrate this, but what happens here if I need to change a tag? I need to like touch a lot of rows. I mean, we could even imagine, instead of having this journals table, we could again decompose the journal title into the entries. And strictly speaking, it's like the same structure, kind of. Like each entry, I can still find all the entries for a given journal just by searching by a certain title. I'm here assuming that all the titles are unique, which maybe that's not true, but maybe it is true. Journals should maybe have unique titles. But this, I think, makes it more clear what the problem is, which is that like this data structure, or this structure, and then this one are both like progressively more denormalized. So normalization is the process of making sure there's no redundant data within your database. So the idea here is that if say I were to do this thing where I identify which journal an entry is part of just by having the title in the row itself. So first of all, it kind of seems like maybe we're duplicating the string a whole lot. Let's pretend the database deals with that somehow, but like they're all pointers to the same thing. Okay, so I'm not storing a whole bunch of data. We still have, so if I change the title of this journal, now I have to update all of these rows. And if I need to look for all the entries within a journal, which is a pretty common operation, I need to do string comparisons on each of these rows, which are far more expensive than just comparing a number, than looking up, like, okay, here's the journal ID for this title, and then looking for all rows that have that ID. So the first argument is more compelling to me than the second. The first argument means that it's like conceivable. The more places a piece of data is duplicated in your database, the more possible it is for you to screw something up and have two pieces of data that should be the same but actually disagree. The canonical example of this is like you store someone's birth date both in their like row as a person and their row as an employee, if you have some sort of like contact list employee information system. And then if there's a bug in the software and it updates one and not the other, now you went from knowing their birthday to not knowing their birthday, right? Which is not good. And so we try and avoid having multiple sources of truth for any given piece of data.
Just go back to these two slides, the best one.
Mm-hmm. So all that said, sometimes you will intentionally denormalize a database for performance reasons, because now in order to like find all entries within a given journal that are tagged by a certain thing, which is not uncommon as an operation, you have to touch every single one of these tables at least once. You have to do, it's like actually kind of a big join. And those joins can get expensive. There's obviously, the database like tries to optimize them. You can give it all sorts of hints that it should optimize that. But as your data model gets more and more complex, that can become challenging. And so sometimes you will have to just denormalize like all of the tags that are applied to a certain entry into an array on the entry itself, or into a bit mask on the entry itself. Yes.
So what's interesting is in that last table that you showed us, where like you were like you want to minimize the number of repeats, you want to get the repeats, but in the date column there may be a lot of repeats, right? So when do you decide like it's okay if this piece of data repeats a lot, as opposed, you know what I mean, as opposed to saying, well, let me just start a new, file that has these particular columns.
Right, good question. So one answer is that the date is conceptually attached to each entry and still only exists in one place, right? Maybe I created 2 entries on June 3rd at 2 p.m. Like the date will actually be the full timestamp. Even if like I have a few identical dates, they're not really representing the identical piece of information, right? They're not representing identical facts. The fact is that like this entry, that I'm pointing at rows that aren't in rows. The fact is that like this entry and this entry were made at this time. And even if these dates were the same, oh, these dates are the same. So these two entries represent, or these two fields represent different facts. This says that Happy Times was made on April 3rd, 2016. This says that An Anatomy of Pain was made on that same day. Presumably, there was a breakup that happened right there.
But describe those means
Yeah, I don't know. I think maybe I was just like writing in my journal and that last entry.
Something happened between you writing the title and then writing.
Yeah, I decided to create a journal to reflect this new single state of my life. This is very vulnerable to talk to you.
Our example says, what happens when I want to choose? Right.
Oh yeah, that's right. There was a whole story here. Okay. Did that answer your question? Yeah. Okay, cool. All right, so again, in overview, these are the steps for coming up with one of these fancy schmancy happy diagrams. You want to figure out what the things, what the nouns in your application are. You want to figure out their relationships. You want to draw the rough ERD, where you just sort of conceptually say, okay, this thing has many of these other things which have these properties. Fill in the cardinality. It's a separate step, so you can say like, this has many, or this has one, or this belongs to another entity. And then you start fleshing it out such that you could define a table. So come up with primary keys, label which columns hold foreign keys, and then figure out where all the attributes live and write them down. Entity relationship diagram, which is one of, this is like a schema diagram. The ERD is actually this thing. So actually the last slide should probably say steps to coming up with the schema. And you can, if you Google entity relation diagram, you'll find there's a whole visual language of like entities are boxes and properties are bubbles and arrows mean like a specific thing based on which way they face and all that. You don't really have to worry about getting all that exactly right. But if you're the kind of person who like really like gets into that sort of visual language, totally look it up and you'll find a bunch of guides on it. Yeah.
So this is an actual diagram, like if you were going to build something out, you show that to people, they would kind of understand that.
Yeah, definitely. Like but you can definitely show this to people and people would get it. There's also like, there's a special kind of arrow for has many. I don't remember what it looks like. It has like a cross on one side or something, and then there's another, you can like specify the types of those through some other symbol. I'm not a database engineer, so I've not like done a billion of these and I know that visual language. Nobody, I think, will expect you to be like super conversant in it. You won't get an interview that's like, given this entity relationship diagram and it looks like a circuit board, come up with a table schema. That has never happened that I know of. All right. So it's time to go really. So we'll do the actual workshop tomorrow morning in the time slotted for presentations and just like shuffle things a little bit. The workshop, which you can think about but do not have to work on, and in fact don't work on it together with your group, is to design one of these. Design the schema for one of these. And if it's a big one like Facebook, feel free to be like, we're not thinking about events and ads. Like, all of these have some crazy ad schema that is pretty invisible to you, but when you think about it, must be there, right? Like, advertisers need to say, like, I care about having my propaganda be broadcast to probably liberal voters between this and, you know, but that's, you don't have to worry about that. Just choose one arbitrarily as a group. If you want me to assign them, I can, but I also don't want to assign ones that you'll hate. Yeah, we'll present. I'm like 90% sure that we'll present. It's just, oh, sorry, I wanted to keep that up. If we don't have time in the schedule, then we'll do something else. We might do like lightning presentations, like 1 minute, here it is. You're going to, aren't you? You're going to start thinking about it. I don't want anyone to feel like they have to. Well, no. You'll have time tomorrow morning and then like a lightning presentation, right? We might do like do it on one of these whiteboards and just talk about it in front of the whiteboard. Yeah. Yeah. Trusting the process. Yeah, meet with your groups for like 10 minutes, maybe like figure out what you're going to do. If you want to think about it overnight, you can think about it. I just think I don't want like anyone to feel like they have to like do a bunch of homework tonight, and if some people are doing it and some people aren't doing it, then everyone kind of feels like they have to, you know? So that's why I'm like, don't work on it tonight. But do meet for like the next 8 minutes.
Well, yeah, so just type in the city. So you can find a room it's like a hotel search, but it's it tends to be cheaper than a hotel. It's really good for larger rooms because you can like 10 people and just like rent out a whole half and then like there are ones to really just stay with your folks. So you just get a room with them. My dad's been let's see. like say we want to set those and then you can filter. Okay, so obviously, I guess we need to keep like the column for availability. Yes. And then like it's okay. Yeah, because then what is it called? Normalizing that?
So one home has many availability days.
Yeah, and then okay, great. So we have so then with all of the